Okay, this is the question set for the first Intro to C video. I am going to take a look at the stream now and see if there are any test. Now that's what we wanted. You can see in here we've essentially, when it created our automatic project for us, it created a solution called test, and it put inside it one default project, which is called test. And the reason I call it a default project, you can see it's bold, is because you can actually go in here and there's a default project, you can see it's bold. It's because you can actually go in here and there's a thing called set as startup project and some other things like this. There's basically a notion of what the project is you're going to build when you build the solution. Because we could actually stack other projects in here that build other programs, which we don't all want to build. and other sorts of nonsense like this. Most of that is not really necessary when you're doing development unless you start developing on a very large and complex project. But if you're just building a game by yourself, it's unlikely you'll need to ever do anything like that. And I often don't build anything from here. So one of the things we're going to cover later is how to build things without using this. But that said, test is the project that we will build when we do build solution. And so what this was telling us here is it was going to build that project. And there's a configuration line which says debug win32. And what the configuration means is basically what sort of build it was trying to do. Because as we'll see later on, there's actually multiple ways you can build the same set of C code. Some of them are designed to target different platforms. For example, you may want to target a 32-bit copy of Windows or a 64-bit copy of Windows, and that would be part of the configuration. You might also be trying to do things that are based on like a debug developer build, so something that has a lot of test code compiled into it. Special menus for you, the editor for the game or something might be built in this mode, but then there might be another build called release or retail, depending on how you do your naming scheme, which will build these things out. And so basically configuration is something that affects the way in which these text files are actually interpreted by the various things that we do in order to get to an application that is somehow different from the other configurations that we might build. So now the next line you can see here is compiling. And what that is compilation is the general term, actually a very general term that technically means moving something from one format into another, basically. Versus the means to some line to execute that family. But the compilation step is basically in charge of doing the majority of the work to translate our text file from something humans read into something that a CPU can read, and specifically oftentimes a specific processor, meaning the compilation will be compiling from a text file into, say, x86 code or x64 code, something for the actual CPU that you are trying to target, not abstractly. So, given that, after we see the compilation line, we know the compiler has started, and we now go to a list of what files it's actually compiling now. We only have one file, which is test.cpp, and so, not surprisingly, it tries to compile that file. Now, you will note, in front of all of these, there is a little number with a sort of greater than symbol. And what that is totally irrelevant for the most part. To what you're going to be doing for development. It's not really something you need to pay attention to, but just in case you were to what you're going to be doing for development. It's not really something you need to pay attention to, but just in case you were wondering, if you are on a machine that happens to have a lot of processors, so if I go in here, if I basically just use the hotkey, one of my favorite hotkeys, Control-Shift-Escape, to bring up the task manager, you will notice that this machine has a lot of processors. In this thing called CPU usage history, there is one of these for every logical processor in the machine. Now, a logical processor is, or I shouldn't say logical processor, perhaps that's the wrong word. I'm going to stick with logical processor. Now, logical processor is not an individual processor. It's basically a logical unit that can run code. And there's two different kinds of these. And we might as well talk about them now, although I'm going to talk about them even dozens. But other machines have 2 or 3, physical synchronizing action, or they'll talk to the bus, they'll talk to processor box, although it doesn't actually say Xeon. It is a 2-processor box, although it doesn't actually tell me how many threads how many cores per processor it actually has. But we could go look up what a W5580 is, and we could see how many it has. But I
Hey everybody, Matt Colville here. As I mentioned in the update video, I started running a new game as a break from the chain. We played online using Fantasy Grounds, and I invited some of the regular crew, plus some new folks who live far away. That's a
You guys are still in the Festive Goblin. Only a few moments have passed since the fight resolved. The people of the inn all recover, but many of them, the ones who are displaced by the fight, are just kind of like standing against the wall, and they're just watching, somewhat alarmed. A couple of them are, I would go so far as to say, horrified at what they just saw. And the innkeep walks up and surveys the dead bodies. Oh, that's right.
But of course, my lady.
Hey everyone, this is a bit different from what I usually do, but I rediscovered this old slideshow I did a couple years back for a talk, and I figured since I probably have a bunch of aspiring game developers following me, that might be at least a little bit of some helpful advice in there. I'm gonna go through this whole thing like very lightly edited, since I don't want to spend a whole lot of time whenever I make YouTube videos, just because I feel like that kind of thing can very easily get in the way of like actually making games. Hopefully, even if you don't agree, because this isn't like authoritative, I'm just a guy. So we start at the obvious place, which is starting. So that this is one that I added in because I feel like this is something that a lot of people get or whatever was thing about was mentioned projects and stuff, mostly for homework when I was part of a game design course. The important thing about the small games aspect is that it should get you used to the process of actually creating, start from the project and actually so big project. Originally did the smart choice, or actually the school did the smart choice for us of setting us on forced you in like that. It was showing the basics of how it's even making days. I think they're in the making just do it or something. You just did my your experience, but I think that's the point across. So we can move on. The one thing you should probably, this really depends on the developer, but my personal advice, or at least from my personal experience, it's better to avoid going completely solo if possible. Working on the game, because for an example, Ultra Kill, I do always before you get to the point where it seems like you actually might be able to make the game. It's after easy to miss. After starting comes the making.
Hey, what's up guys? My name is Eterno. Today I wanted to answer a question that I get asked very often. What do I do next in my C++ learning journey? Now this is a very common and fair question. I've been teaching C++ on YouTube for quite a few years now. I've also been teaching students one-on-one privately as well. And they seem to get through all of this teaching content rather easily. Whether it be my videos, whether it be C++ textbooks, or even university courses, they have no trouble learning the concepts from all of that content as well as even sitting exams. But what do you do next? What do you do once you've been taught C++, so to speak? How do you transition into actually being able to write C++ code freely and more or less speak C++ fluently, if you may? I'm gonna sum this up in just a single phrase for you right here, so it's really nice and simple. Open source projects. You need to start looking at other people's code. Actual real-world C++ code, not examples in textbooks, not the kind of homework that you get from
C++, a statically typed compiled programming language famous for its widespread use in software infrastructure and infamous for its steep learning curve. It was created in 1979 by Bjorn Stroustrup at AT&T Bell Labs. He was inspired by the object-oriented nature of Simula, but needed a language with a high performance of C, and thus C with classes was born. It's designed as a superset of C, which means that virtually any C program is also a valid C++ program, but it also adds zero overhead abstractions, such as object-oriented patterns like polymorphism, encapsulation, and inheritance. Today, it's used in a wide variety of systems with constrained memory demands, like the Unreal Engine for AAA video games, programs like Adobe After Effects that were used to edit this video, databases like MySQL and MongoDB, embedded systems like the display on your smart toaster, and is used to implement much of our low-level infrastructure like language compilers and virtual machines. It's so popular because it provides low-level memory and hardware control like C, but with high-level abstractions like classes and smart pointers. C++ makes it harder to shoot yourself in the foot, but when you do, it'll blow your whole leg off. To get started, install a C++ compiler like GCC or Clang, then create a file ending in CPP. Include IOStream from the standard library to handle input and output. Your code will start executing from the main function. To print hello world, we simply use standard character output followed by the bitwise shift left operator and a string literal. We can get rid of this std though by adding a namespace to the top of the file. Now if we want to create a string variable, we can do so by typing it as an array of characters. However, if we include string from the standard library, we can use the string type instead. The real game changer though is the fact that C++ supports object-oriented programming with classes. A class is just a blueprint for an object. Inside a class, you can define
you
attributes and methods that will be private by default, or make them public by adding them under the public specifier. It's also possible to define methods outside